Welcome back. Going to do something a little bit different. It's very much the same today. So on a previous video, designed a picture frame basically, and made several of them. And basically, this is the idea was that I made a 3D picture frame that out of flat pieces that was assembled, and then I engraved something in the middle. So I made 6 of them all together, and 4 of them came out looking just right. 2 of them, however, kind of bowed, and I figured out the reason for that is the centerpiece is relatively large. It doesn't get a whole lot of heat, all things considered. The side pieces are relatively small, and like this piece, it's just all heavily heated. And it actually, when I measured it, it actually shrunk a little bit because you, I dehydrated the wood, and the wood gets smaller when you dehydrate it. Just the little bit it was, since everything was so tight, that was enough to make the thing bow, which is not hardly ideal for something you're going to hang against a wall. So I came up with some ways to fix it, went back to the original file, and after I had implemented all of those, the file was absolutely huge. Doing a regen took like over an hour. And sometimes it would even fail to regen. It would and not even tell me about it. I'd look and I'd see that, hey, this thing didn't regen. I regen again, and then it regened right. But then I'm not even sure if it regened right. It just kind of looks more right now. Maybe it's still wrong because I wasn't alerted to the problem in the first place. So basically, I decided there's so many problems with this, and I intend to make a good number of these. And I'm going to have to regen them pretty much every time because that's how wood is. So I just started over. Um, and I'm not going to show the process of doing that from start to finish because it was incredibly long process, and quite frankly, a lot of things I had to try to keep in my head, and talking while I did that just wasn't going to work. So instead, what I'm going to show is I've got the completed part, and I'm going to go through the model tree and show what I did, just to give you an idea. Like, this is the same thing as we did before, but we're doing it in a different way. And that's one of the things that you run into a lot of times in CAD is you might have 5 or 6 different ways of doing something, and you gotta sometimes you just gotta choose between 2 of them that are equally good. Uh, sometimes you got a couple options that are really bad, but they will work, and maybe you resort to them because the other methods are just causing errors for no reason. Um, CAD and SolidWorks is my favorite CAD software. It seems to be the most reliable and capable of anything I've tried, but even then, it's far from perfect. So, show you another method, and maybe you get maybe you'll get an idea out of it anyway. So the first sketch is scale 1, basically the same as what we did in the last one. Basically, this is just a bunch of math. So ultimately, it gets us, you know, Y tooth wide. I've got X tooth wide. I've got the total X count teeth, same as before. So this isn't actually used to generate geometry directly. Basically, it's just used so I can say this feature that I'm making should be equal to this, or this divided by this, or something like that. And let me roll back here. So I went ahead and started with basically just making 1/4, the top left quarter of the back plate. And so I drew that up, and I already knew that this was going to be 2 times the material thickness, and then there was going to be 5 spots worth of material thickness width. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And so I went ahead and made the teeth also when I was doing that. And then these two teeth are made by this sketch, and that is based on the tooth thicknesses I generated here. So the first 5 width is where the border is going to be, so that's all done in just being equal to material thickness. Whereas these are calculated out because it's a longer run, so you don't notice if they're a little bit off because it's divided out amongst a lot of teeth, and that way I'm not restricted to having it a multiple of the material thickness. I can choose the width I actually want and let the number of teeth sort it out for me. And I only made the first tooth in the pattern, so that comes in important. So then I drew up the side one, and you'll notice there's a lot of equations here. And the reason for that is that nothing is really constrained to the geometry of this piece, or this body. It's all based on the original, the formulas from here, formulas from here, and there's a couple of constraints just to orient the whole body, but like the size of these teeth and the positioning of them, it's all based right inside this sketch. And the reason I did that is because I don't want it to be dependent on this original part in case something changes. Not a huge deal at this point, but I wanted to get into that habit because it's going to be really important as we get more and more complex going forward. So then this sketch, this is just an extra cut, I believe. Okay, so this is the original just square basic. And then this, what I did was well, first of all, I added something that's called finger side space. So basically, I just wanted to be able to make the openings between the fingers a little bit larger. So again, if there's a little bit of shrink or swell in the wood, it doesn't cause the whole thing to bow. So basically, I made this section here that it cuts a little bit off the side of the finger, and while I was at it, I also did the chamfer. And I just did that for all the existing teeth. And again, I only have the teeth that are material thickness, and then the first tooth that is based on the formula that's not material thickness. And then I do the same thing on the back. I make the back one, and then I add the offset and the chamfer. And let's see. Then here, let me hide these. I went ahead and made the first square, where the inside square here is where the square would be in theory. And then I offset it by, again, by this finger side space, which it's actually that divided by 4, because it's on either side, so that's divided by 2. And then that's applied not only to this, but also to the thing going into it. So it needs to be divided by 4. And every time I use this finger side space, I divide it by 4. So it's 0.025 in this case, but if I change it later, it'll adjust. And again, these are all located by their actual, based on the math, as opposed to geometry. I think this I did a coincident on, and that was it. Everything else was based on math right here in the sketch. So got this finger, then I went ahead and offset it. But you see in this one, since the piece of wood is going this way, I'm not too concerned about it expanding this way. I mean, it might, but if it does, that just makes it tighter in the hole. It doesn't cause it to warp the whole product. So the final piece that I made doesn't cut off this part, but it does cut off this section. And one other note is that on all these, I'm selecting the original rectangle, and then I'm offsetting it. And by doing that, then I can constrain to it, And if something changes radically in size, it doesn't flip and go, oh, you want it to be this far away. Well, if it's down here, it's also this far away. By offsetting it, it's coincident to that. That's outside of it. And SolidWorks, when it regenerates, goes, okay, that's outside of it. It's coincident to that, and it doesn't end up backwards, which happens sometimes. It's not very common, but it does happen. And when you're dealing with things this small, you're likely not to notice it until you try to put it together, and then you got to track down what happened because it's not going together. And basically the same deal in this direction, just different formula because we've got different, this is the Y tooth width, this is the X tooth width, and then this is equal to that. Yeah, so, and also I just made the first tooth in the series again. And that'll be going throughout. I'm just going to be making the first tooth in the series. And the reason for that is if I were to make this first tooth, if I was to make this whole pattern right away, and then I've got maybe, well, depending on how big it is, I might have an extra 100 faces or 200 faces, depending on how big I tell it to be. And then I've got another 200 faces here. So now I'm drawing this like in the small size, and this is face, I don't know, 80. But then I regenerated the big size, and now face 80 is like here. And it throws everything for a loop. So what I'm doing is basically what I'm drawing is always going to be there no matter what. And I'll worry about the generated stuff that might or might not be there afterwards. So, and I'm going to show everything again. All right, so here I just generate the inside border. And again, this was based on just geometry inside the sketch. It's not based on being attached to, say, these holes in here, because those wouldn't be very useful for this anyway, since they're already offset. And then I do a cut, basically for the spot between here and here. I just want to make that first cut. And if I hide this, you see I just get that first cut. And then I also need a cut for where the other piece that is going to be here will notch into it. And then I went ahead and added just a little bit extra material so it's actually going into a closed off hole, which if you can do that without showing it, it's a good idea. Sometimes it's worth doing even if you have to show it, because it makes something a little bit stronger and easier to assemble and all that. In this case, I'm trying to make it look as presentable as possible. And I think in this particular design, having this on all the contact edges and closing in all the fingers would not be ideal. But since this won't be visible, I took the chance to use it. And here, you probably didn't even notice a difference, but I just cut that little bit extra off for the finger side space. And then I went ahead and made the chamfers. And here I make the piece that's going to interact with that. This is just a rectangle at this point. And so then I cut a bunch of pieces out of it so that it's the basic theoretical shape before all the flourishes are added. And again, I just take little tiny cuts on here, and here, and here, and also here and here. And then I add chamfers. Side note, I did the chamfers as a sketch. In this case, you could use the chamfer tool. It probably would have made more sense. I just wasn't thinking that way. Again, you can do things multiple ways, and sometimes the way that just comes to mind maybe isn't the most efficient, but it works. And again, just make a rectangle to get a good basic idea of what the piece is going to be cut out of, basically. And cut all these out. So these are all this whole section is all, these teeth are as wide as the material thickness and as deep. And then the first tooth here, well, the sixth tooth, but this is the first tooth of the pattern that will not be with the material width. So my material width is 4.41 millimeters, and this first tooth is 4.759. Which on a small one, you'll get quite a variation like that. You know, we only have a few teeth to work with here. If when I'm making it larger, you know, it's got 40, 50, 62 teeth, that difference is much smaller, and it goes from 4.4 to 4.759, whereas when it's a large size one, it might only go up to 4.5, and you'd be hard pressed to see a difference of 0.1 millimeters, especially in something wood. And let's see, this is just cutting off the extra the tooth side distance, and then adding the chamfers. And then I make this piece. I went ahead and I believe in this one I went ahead and did a little bit more than just make a rectangle. So if I hide everything else, yeah. So I did a little bit more than just making a rectangle in this piece. I made, you know, the basic design right away. And then I offset just a little bit, you know, on these. And this time, but by this point, I'd realized, oh wait, I can just use the chamfer tool, so I did, and it saves a little bit of time, obviously. And I need to show the rest of this. So, highlight in blue, you see 4 rectangles. And what these are is these are the base of where I'm going to connect the text, which I can't put the text in yet. Partly because I only have a quarter of the thing, and partly because if I put in the text before the very last step, it's going to add a whole bunch of extra faces, and that's going to cause problems in other features down the line. So I just wanted to put something that I could anchor the text to later. So what I did is I just put in these. So I made a rectangle here, another rectangle here, and I made this equal to the text height that I'm using, which is right in here, text tall. And I also have this text base offset, which some fonts, the bottom of the font will be right touching the line that you draw it on. Sometimes they'll be above, sometimes they'll be below. Most often they're either right on the line or above, though. The particular font I am using here, at 10 millimeters tall, is this far above the line you draw it on. That changes depending on the height, but I'm using 10 millimeter tall, so it's always that far above. So what I did was I made this rectangle as the ideal spot that I want the text to be in, and then I made rectangles to the side that are, so if I base the text here, the bottom of the text that you'll actually see will be right there. And I did the same thing here. If I start writing text using this line, the actual bottom of the text that you see will be on this line, and the top of the text that you see will be on this line. And if I flip this thing upside down and I want to start text here and have this the top of it, you know, if I flip it around like this, I basically just got the same thing that I can work on. So I can base text here, the bottom will be here, the top will be here. And so yeah, I just put those in. I could have put them in later, but I thought of it at the time, so I did it. Sometimes I do that. Let's see. What's this one do? All right, so this is actually kerf already. Even though I've got only a quarter of this done, I figure, actually I have less than a quarter done because I don't even have these teeth. I figure might as well do the kerf early on when there's fewer things to worry about kerfing, or do the kerf offset early on, so there's less things for it to have to process. So I did the kerf there, I did it there, and scroll down a few, did it in that piece, on that piece, and this piece, and then this piece was a little bit more because all of these I just offset the face, and it was nice and easy. Only difference is that when I did these, I also had, after offsetting the face, I also had to do a convert entities on these so that they wouldn't get covered up. On this one, let me hide all the others. Oh, I should have kept that and hide this. All right. So on this one, in addition to doing the offset face, I also had to offset these. So I offset these in, and these are just construction lines. And then I offset the outside out. So basically when I did the extrude boss here, it just completely overwrites the existing piece that had been there. And let me show everything again. So in this case, at this point, I'm actually starting to work with doing the patterns. So this is the first place that I'm actually starting to use patterns. So we're a good ways down the tree, so anything I do in here isn't going to mess with it. And I'm basically at the end of the process, other than doing the patterns and so I do the patterns here to cut all these teeth going forward, and also this way. So let me show this again. So this sketch is basically before I do the tooth cut, and then I've got my teeth cut. And this looks a little bit wrong because it's, half a tooth. It'll look right once it's all sorted. It's fine. And let me show everything again. So then this is the teeth for this one. So if I get this out of the way, now it's got teeth all the way down, whereas this back one didn't. And teeth back there, teeth up front, teeth there, and teeth there. Just keep adding teeth there, and let's see. Okay, so now I've got teeth patterns on all of them. Which at this point I've got to be real careful because as I change this, if I make this twice as wide, I'm going to have like twice as many faces. Things get real messy real fast. So what this sketch is I just sketched right on one of my original planes. I made a big circle. I constrained it to the origin, which is right here. I just gave it a huge size. I made it 2,000 millimeters in diameter, which is big enough to cut any size thing that I would make that would actually fit on my laser cutter. And I guess if I really needed to do something bigger that was on a bigger laser cutter, I could just make that circle larger. But 2 meters across, even being generous, or worst case scenario, that's a part that's like a meter across. It's pretty big for a picture frame. And here too. So basically I made a circle here and a circle here, except they weren't actually on these planes. They were on the original planes. And I just cut off a tiny little sliver that we had extra from doing the kerf, because I don't want that extra for the next step. And the next step is this. I mirrored it across that same plane that I used to cut, and then I mirror all that again. So right there in 2 steps, we go from having a quarter to having the whole thing, although it's cut up into pieces. Like this back piece is 4 pieces, and all the other pieces are 2 pieces. So at that point, we do a whole bunch of combines. Combine this with this, this with this, this with this, this with this, so on and so forth, so that all our pieces that are cut up into 2 or 4 pieces are now singular pieces. And at this point, I've got it completed. I can hide this original sketch, and I can move pieces so that they're flat, so that when I export this to my laser cutter, I don't have to worry about the being in wrong orientations, because it can't cut them in the wrong orientation. It has to be looking at them just like this. And then from there, I first make a sketch, again basing it off of these rectangles that I had made before, and I don't actually cut any text with this sketch. All I want to do is I want to make the lines that I can put the text on later, because the next process is just to make little bits to fill in those squares. I just want to fill those in so that when I export, I don't see those squares at all. And then the last thing, the final thing in the entire part, is the actual text, which all I did here was I selected this sketch, I select convert entities, and then I could base this text on top of that. So that's the final everything involved. I'm still got a little bit of fine tuning to do with my settings. For instance, when I first did this, I did my finger side space as 0.20 because I figured worst case scenario I'll use a lot of glue. And I used a lot of glue, so I'm gonna try it maybe at 0.10 and see what happens there. But it did go together, and it's no bowing, and I don't have to worry about it bowing over time. So I'd call that a win, even at my worst case scenario there. So that's basically what I wanted to share today. Is that, again, lots of different ways to approach things. Sometimes the most obvious way is not the best, or it may have problems that you wouldn't have even considered before. But just for an idea, again, the original one that I designed took over an hour to regen. So I'm going to click Control Q right now, and it's just gonna be spinning there, and it's done regenning. So that gives you a different idea of the difference. Any questions? Feel free to comment. Otherwise, like, subscribe. Don't do anything. It's up to you. See you next time.